Therefore, this is L into what is d square q by dt square minus omega square qm into sin omega t plus theta plus r into what is dq by dt omega qm into cos omega t plus theta plus what is q by c 1 by c into qm sin omega t plus theta. This is equal to Vm sin omega t. Now we will simplify this whole equation like this. Now please see. Omega qm minus omega qm sin omega t plus theta I took minus omega square qm as minus omega qm sin omega t plus theta into omega L plus, and this one omega qm into r cos omega t plus theta plus that is qm sin omega t plus theta by c is equal to Vm sin omega t. I am taking omega qm as common in the whole equation of the LHS side. Omega qm as common. What we can write? R cos omega t plus theta plus, and here also omega L minus omega L into sin omega t plus theta. What about this equation? 1 by omega c into qm sin omega t plus theta. Is equal to Vm sin omega t. Now, omega qm into r cos omega t plus theta. This is 1 by omega c into sin omega t plus theta. This is omega L into sin omega t plus theta. So what we can write here? We can write xc minus xl into sin omega t plus theta into qm. Now I am taking omega qm as common in the LHS side of the equation. Therefore, if I took omega qm as common, so what we can write? R cos omega t plus theta minus omega L sin omega t plus theta. And here also qm is already common, so we can write 1 plus 1 by omega c into sin omega t plus theta is equal to Vm sin omega t. Therefore, the equation turns like this: omega qm into r cos omega t plus theta minus or plus 1 by omega c. Here also sin omega t plus theta is common. So therefore, we can write plus 1 by omega c minus omega L into sin omega t plus theta is equal to Vm sin omega t. Therefore, we came to the last part. Omega qm into r cos omega t plus theta plus 1 by omega c minus omega L. It is xc, it is xl. into sine omega t plus theta is equal to Vm sine omega t. This is the simplified form of this whole equation. So we got omega qm as common, r cos omega t plus theta plus xc minus xl into sine omega t plus theta is equal to Vm sine omega t. Now we are solving this whole equation by taking r is equal to and xc minus xl is equal to different terms. So we got an equation like this: omega qm into r cos omega t plus theta plus xc minus xl into sine omega t plus theta is equal to Vm sine omega t. I am multiplying and dividing with z on the LHS of the equation. Multiplying and dividing with z on LHS of equation. So multiply with z, omega qm z into r by z into cos omega t plus theta plus xc minus xl by z into sine omega t plus theta is equal to Vm sine omega t. Now let us write r by z is equal to cos phi and xc minus xl by z is equal to sin phi. What is the reason? Our first work is to simplify the equation as simple as possible. So omega qmz into cos phi into cos omega t plus theta plus sin phi into sin omega t plus theta is equal to Vm sin omega t. So the bracket part, which is in a form of cos A cos B plus sin A sin B. So cos A minus B is the solution of this equation. Therefore we can write omega qmz into cos omega t plus theta minus phi is equal to Vm sin omega t. Now we are going to the comparison from LHS to RHS. So qm omega z is in the shape of Vm and cos omega t minus phi by 2 is equal to sin omega t actually. That means we can write theta minus phi is equal to minus pi by 2. So we got the equation like this: qm omega z into cos omega t plus theta minus phi is equal to Vm sin omega t. Now I am trying to compare the whole equations. Vm qm omega z. Vm is equal to qm omega z, where z is similar to the resistance. That's why what is Ohm's law? Vm is equal to Imz. Therefore Im is equal to qm omega. This is the one equation we got. Next one, cos omega t minus pi by 2 is equal to sin omega t actually. So we can write cos omega t plus theta minus phi is equal to sin omega t. This is the actual equation we got and this is the actual rule. So by comparing this one we can write theta minus phi is equal to minus pi by 2. Therefore theta is equal to minus pi by 2 plus phi. So these are the solutions of the Im and theta. Now we are going to substitute these two in current equations. So we got the equations like this. I is equal to Im cos omega t plus theta, or Im sin omega t plus theta. We already got the solutions for Im. What is Im? Omega qm. That's why we can write qm omega cos omega t plus theta, or qm omega sin omega t plus theta. And one more thing we have got like this. And we got Im is equal to Vm by Z. Therefore, Vm by, what is Z? Impedance. The equation is under root r square plus xc minus xl whole square, where tan phi is equal to xc minus xl by r, and phi is equal to tan inverse xc minus xl by r. So these are the solutions we got for the values Im, phi. So this is called analytical solution or analytical solution of the series LCR circuit. The next one we are going to see is resonance condition in the LCR circuit. Now we will see the resonance condition of the LCR circuit. What we can understand about the resonance? When inductor, capacitor, resistors are connected in series, which is connected to a AC power source, these LCR circuits have a tendency to oscillate at particular frequencies. This tendency is natural, not by forced. So that's why the frequency of the tendency to oscillate at natural level is called natural frequency. That means, I am repeating again, this LCR has the tendency, LCR circuit has the tendency to oscillate by its own at certain frequencies. This frequency is called natural frequency. First condition, natural frequency. Tendency to oscillate by own at certain frequencies. If any external energy is driven the LCR circuit, external energy is driven the LCR circuit, then the LCR is experiencing the forced oscillations. That oscillations will mix with the natural frequency, then the amplitude of the LCR circuit will be maximum. Therefore, external driven, or we can write like this. Driven force. So the external force which is applied on the LCR circuit in a form of AC circuit or in a form of any other thing. So an external source which drives the LCR circuit. So it's a natural frequency and this external frequency both will mix it out. If the both are at same, then the amplitude will be maximum. Amplitude. This is called resonance. What is the meaning of resonance? If two objects are vibrating with the same frequency, the resultant amplitude of the two sound waves or two mechanical waves is maximum. That condition is called resonance. In case of mechanics, the resonance depends upon the air column, but in case of electrical circuits, the resonance depends upon frequency. What is that frequency, what is the condition, and what is the impedance relation we are going to see now.
If you like this video, Please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.